Hello everyone, welcome to another little video. Today we're going to try to get a little program running that uses Vault-Lane, which I showed last time a little bit. If you haven't watched that video, you can go watch the first 10 minutes. I explain roughly what Vault-Lane is, but you'll also get it by just listening to this one. If I sound a little tired, it's because I had a long day, but I really do want to program and I think it's interesting enough to record it. So let's do that. So first of all, I've added C bindings now. So what I'm going to do is I'm going to rebase and merge this one really quick. There we go. Because now it's in here and it should now be, oh God, I hope it signed it. Oh, it didn't sign it. It's fine, whatever. I have to figure that out eventually. Yeah, okay, fantastic. So what I want to do is I want to write a little chat server and a chat client so I can basically enter my name and then I can be like, hello, and then someone else can enter their name and they can be like, hello, and they can see the message that I said and I can see the message that they sent and just sort of do that with TCP and everything. And I can actually write the client in C if I wanted to. I'm still not sure if I want to do that. I think I might. But we'll see. So first, let's write a server. So the wonderful thing about this is that I can just make a new project. Let's do cargo new. Just write the server in Rust, right? So this is simple, or let's call it Vault-Lane, or yeah, Vault chat. Why not? Right? Let's call that. What are the arguments here? Can you say it's a workspace? You cannot. Okay, fantastic. So Vault chat. And let's actually add that here. Which is gonna be source Vault chat. There we go. There it is. And we're just gonna do that. All right. And there's one dependency that we'll need for Vault chat, which is the what's it called? I think just net. I think that's the only one we need. Maybe enc, I don't know. But essentially, I think the way this works, and call me silly, right? But I think you can just be like net git, and then it'll tell me I could just use this thing. Let's see if that works. Let's try that again. All right, I copy pasted something wrong there. Oh, whoops. Yeah, sorry, not SSH. I want HTTPS. Copy that, and there we go. Fantastic. Okay, so let's open a. Oh, well, let's do just cargo check, and that didn't work. That did not work. All right, unresolved import Tokyo IO async red extension. Oh, right. I probably also need Tokyo. So let's do cargo add Tokyo. Features full. And I'll get into what I'm doing here in a second. I mean, I've already explained it, but it's gonna make sense in a second. All right. So let's close everything else and let's just start fucking coding a little bit. So I'll have a Tokyo main function. Function async function main, and that's going to be that. And now I really just want to copy out the echo server example pretty much. So that's why I wrote examples, right? So you can just go in, look at the code, see what you like, copy that shit. I'm not actually going to copy it, but I'm saying you could do that. But realistically, all we want to do is just the same thing, right? So let's type this out manually. Do I have let's turn off Copilot for a little bit because it's going to be a little bit annoying. So a listener is going to be a TCP listener, which is a Tokyo net listener. I'm going to bind to 197.001.42.001 because that's like the default address of that the connection server expects at the moment. Like you can configure it in the connection server toml, configure all sorts of stuff, but we're not going to do that. And just in case you haven't watched the other video, Vault Lane or the connection server is a completely separate binary. So we don't have to worry about it right now. We're just going to write some code with this net library, this one right here. And we're going to write some code with the client com library or the client com C bindings, whichever one. And then we're going to have a fully working TCP chat server and client, right? That's the idea anyways. We'll see how that goes. And of course I do want anyhow, so let's do that. So, because I don't want to deal with it, so anyhow, result, and we'll say, okay, fantastic. So now we just loop and we say, this is pretty much the same as below. Actually do want the address in this case though, so listener accept, await, and well, actually, I don't know if we want to loop. I guess we do. I guess we do want to loop. But this is not our sort of main loop. So this is just the conserver listener. Because this is literally just, so this is the conserver socket and the conserver ADR. And we're going to just do a little bit of a turn line. Well, actually, we don't care about the connection server. I misspoke. Okay. Okay, so now we do the first thing, which is net configure performance socket, conserver socket, just probably mute. Oh, that's not awaitable. Okay, and then we're pretty much done. We now have a working sort of TCP server that can accept as many clients as we want, which is fantastic. So now let's actually do a little loop here. So this is our, oh, well, let's call a function. So what should we call this? So chat name. We'll just give it the conserver socket. I'll write that up here. Oh, we probably want to await that, right? Fantastic. Okay, so and if this crashes, we probably don't want to go do that. Probably want to do if let error is. We probably want to do current line error and then we just sort of blindly continue. It's going to make sense in a second. So now chat main. This is going to be a TCP stream. That's what it is. TCP stream conserver, and it's going to mute, and it's going to be owning, so we don't care, and this returns anyhow. Result again, because there's really no point in us caring right now what these results are. Okay, let's see. I guess I just want to loop, and I want to say that packet is, and we can kind of close this now because I don't think there's anything else in here. No. Let me actually make this a bit bigger. Okay, so this is now net receive. No, not precise prefixed. The server side receives a tagged packet. Okay, so we expect a read. And so the way tagged packet works, there's a lot of documentation here, by the way. You can go through this in the GitHub. It's quite interesting. It's a cancel save implementation of a bunch of different stuff. It's quite fun. But anyways, essentially what receive tagged packet is it receives a packet with a client ID. And what it takes is it wants a framed reader. So we need to make a framed reader, I think. So net, but actually we don't have any readers yet. So if I do new framed reader, it doesn't let me because, because it expects a, oh, it does. I don't think, yeah, no, it wants, like it does technically accept a stream but it's really generic and it just wants an async read. And because we want to read and write, what we actually want to do is we want to split. So when we don't want to mute this. We want to whatever these are, I don't remember. Conserver into split. Read half, write half. That's what it is. Okay, so this is our mute read and this is our mute write. And essentially the way this works is that you can take, so a TCP stream is duplex, right? So you can send and you can receive on the same socket. And what this essentially does is let you say, okay, let me pretend that they're separate halves, right? So I have a read half and I have a write half. And so they're basically just the same socket, right? There's the same reference, the same socket, same file descriptor, same everything. But you're not allowed to write on a read half and you're not allowed to read on a write half. So it's just a type system thing. And I need to drink some water, one sec. Okay, so, and this is basically just a hack to make it possible in Rust to say that one function or one thing owns the reader half and one owns the writer half. Because for example, in C, there's no real way to say, here's a file descriptor, but you're not allowed to read on it, only write. Like, it's a sort of contract. And in C, it would be encoded in a comment that it says all caps, here be dragons, please don't read on this. And in Rust, we have a little bit of a type system thing for that, which is wonderful, fantastic. So, and we can use the reader to make this here, so we don't actually need to call mute. So let read is, and so we'll shadow it, and then we should be good. And this is probably, yeah, it just returns a framed reader. Fantastic. And you don't have to really understand how any of this, like what any of this is, because again, it's an abstraction for a reason, right? So we await that and we say, okay, that's our packet. And so now, presumably the client is saying like something like, hello, right? So client one is saying hello. But maybe first we want to figure out what the client's name is, okay? So maybe we write a little protocol, we write a little a message here. So we add a little bit of a, what do we want to use? JSON maybe, because it's nice and easy. So let's add Serday. And let's add JSON so we can get started with this pretty quickly. We don't have to worry too much about it. And we'll just make a derive, serialize, reserialize, debug, enum, which is going to be our message. And, well, not a message, it's like a packet? No. I guess it is a message. It's not really a message in the sense of like the chat message, but we can encode that here. So that's a chat message. Chat message is just a string and a login request, login response, the string. I think that mostly covers the amount, like sort of the types that we want. And of course you want to import both of these. Fantastic. Okay. So now we have a sort of message that we can serialize and deserialize from into JSON, right? And presumably we're gonna say the packet has a few things. It has a client ID, and we can transform it into a vector. And I'm guessing, right? I'm guessing that we don't actually have access to the content of the packet yet, because again, I'm building the vault lane as a sort of hobby project, so I haven't really thought it through very much. But let's see. Oh, it's an enum. Never mind, I did think it through. So there's multiple things that we can get a data packet, a failure packet, a kick packet, or a reconnection packet. Interesting. Don't remember writing this. I do remember writing it, but we'll see. So we don't care about reconnection right now. We're just going to ignore reconnections because they're free in Vault-Lane. So like if a client loses a connection for a little bit and then comes back, they're automatically re-authenticated and everything by the connection server. So we don't care. And so kick we care about, failure we care about. So these are basically, well, kick is something we send. So we can only really receive failure in data. Failure means that the client failed, which essentially means the client disconnected and failed to reconnect in some amount of time. So it's basically like a fatal error for that client, and that client is now completely gone and there's no way to get him back, right? So it's basically like a disconnect in a sort of traditional sense. And this is just some data that we got from the client. Okay, fantastic. Thank you. Let's go back here and let's match on the packet and figure out what we have. So we have data, failure, kick. So kick we should never get. Because it's not documented, I think, but we should never get a kick message. We should only be able to send a kick message. And yeah, then reconnection, we don't care about. No, let's just do. Well, can we just ignore it? I guess we can't. I guess we can't because it wants to do. It wants to do something like that. Okay. We'll get there. Or I guess we could log it. Why not? Let's log it. So print line client has reconnected. Yeah. And I mean, I can just do this. It doesn't matter. Then failure, well, to do, and this is interesting. So this is our sort of handle message thing, right? And I assume we're gonna be handling a little bit of back and forth type of thing. So let's actually make a struct for this. So this is the chat server. So import chat server function. Well, let's make it public already. And we initialize it with a TCP stream. So stream, and it should probably have a read half, or no, it should be a read, which is a framed reader. So net framed reader of U8, I think is what it is. And the other one is a write of type owned write half. Yeah. So I want to return self, which returns self, which is like this. And so really we want to put this in here. Now we can just get rid of all this. And then this is not called console, this is called stream. And this is the wrong type. So it's a framed read U8. And I found struct framed read, owned read half. Oh, of course, sorry. This is a owned read half, not U8. And of course, this doesn't have to be mutable now that we're doing this whole thing. Okay, so pub function run. So run is going to consume self because I don't really want it to be able to run it twice. Makes no sense because it's sort of never going to finish, right? So let's do that. All right. And now we get rid of that ugly function. And now we can, instead of doing whatever we were doing here, we can now do let chat server is chat server new con server socket. And then we can do chat server. Oh, wait, probably because we're about to have to be awaiting this. And of course, this is the thing we actually want to put in here. So I'm a little bit silly and I forgot. And get rid of this, and then this is no longer going to complain because it's getting a little annoying. And of course, run is not yet isync. So let's make it isync. All right, so this is now self read, which is not mutable. There we go. Fantastic. Fantastic. Okay, now we've transformed this. Should have done that from the get-go, but it's fine. Data. Okay, and so we're gonna need to take the reference to self, and we're gonna take the I guess, if we take the client ID and the data sort of separately, I think we should. However, this is just becoming very, very untestable. So let's be careful what we're doing here, because I do want to unit test this probably, but whatever. Let's just think about this in a way that makes sense. Handle data. I guess there's not much to unit test, so who gives a shit? Okay, so we'll do client ID, which is, I happen to know, is a U64, and data is a vec of UA. And it's going to return anyhow result. And as you know, as you've noticed, we're not dealing with n clients here. We're dealing with one client, which is the entire point, in case you haven't seen the other video, behind Vaultlane. Oh god, sorry for the flashbang. But basically, it collapses n streams into one stream. So you only have to worry about one stream, and each packet is just tagged with the client ID, and then you're good. That's it. That's the entire point of Vaultlane. It's open source, free, it's AGPL, it's everything you want. Just go to vaultlane.net, try it out. It's not fully finished, and it does definitely have some rough spots, but I think it's still worth trying. Okay, self handle data, client ID data. Oh wait. All right. All right. Let me see. We should now deserialize the data and deal with it in some way. Yes, let's do that. So deserializing is done with 30 JSON from slice, I guess. So let message is from slice data. Okay, doesn't like that because it's do that. Okay, so that deserializes it, and now we know what we get. So match message. So now we can look at, oh, what the fuck? We can look at what kind of message we got. So this is unreachable because we should never get a login request from the client, obviously. And login response means that we can now register the client in a vector of clients. So clients is a vector of clients, which is really just a vector of U64s right now. Because we don't have to, hold on, need to drink again, losing my voice. Oh, okay, we're back. I think I'm losing my voice a little bit, but I'm sure it's gonna be fine. So this is sort of the benefit, right? Now we have to only care about clients in terms of a single identifier. We don't have to care about their socket, the socket state, all that sort of shit. It doesn't matter anymore. So this is the content, right? And this is the name. And I guess we can get rid of the login request because the first thing we're gonna get is a login response. So we don't really have to even worry about that. Right, fantastic. Chat message content, and so handling the content is actually not that hard. We say if clients self clients contains client ID. Does it not work? Oh. If that contains it, or I guess if it doesn't contain it, we want to fail that client. So here's where it gets interesting. Now we can say we can say net send text packet, where we say self mute self right, and we make a new packet. So it's net tag packet, which is a kick packet with the client ID, and we await that, make sure that doesn't fail. Okay, and so this is all we're doing to basically say, okay, if our clients list doesn't contain this client, we just kick them because they failed to sort of log in. Right? Our login right now is just them sending us a name, right? But we can't send a message here either. We could maybe send them a message, but we'll do that later. Oh, actually, how about we don't do that later? How about we do server message or system message? Let's make that a separate type. Why not? That's kind of fun, right? And again, if it's a system message, if it's a system message, system message, whatever it is, we just want to fail that client because that's not allowed. So print on failing kicking client because they tried to send a system message. We can actually use the fancy pants way here, the embedded macro meme. All right. Okay, and then we send this tag packet and we're good, right? So for this one, it doesn't really matter. We're actually, in this case, I guess we could send this system message. So let's make a function send system message. Well, it's not that simple. I think for now we'll not do it. We'll just send them a data packet with the well, actually, I think we do want a helper function for this. So pop async. Well, it doesn't have to be inside the chat server, right? So function async function send system message, where we do basically a we want to take the right, which is a new and right half. For us, I mean, we don't really care. And then the string, the message. And what we're going to do is we're basically doing this. But first we need to construct the message, right? So, or the packet. So the packet is going to be a net tagged packet system data with the client ID. So that's the client ID. To client 64, and we do to client data is going to be our serialized message. Okay, and so our serialized message, whoops, message is going to be started JSON to vec, I guess. Yeah, to vec of a message, system message of, here we go. And I'm sure this doesn't work because okay, whatever, we'll make it a string, I don't care. Well, actually, in this case, it's kind of convenient to have it be like that, so. All right, and then of course we do, okay. And that mostly works. We'll get there, So now it's saying we want a reference, that's fine, it's fair enough. And then there's no self-write, instead there's just a write. And we don't have to declare it like that because it's already a mutable reference. And of course, we don't want this, instead we want a data packet. Well, actually, we've already written that. Fantastic. So this is going to be the packet. And I hope this sort of makes sense. I think it mostly does. So we're serializing the system message. Oh, how about we make a more sort of generic one? Send message. And yeah, let's do that because that's much better. Because there's no real reason for us to sort of make this so specific, right? No reason for us to make this so specific. And then this just couldn't go, I guess. Could have just renamed it, but you know, we live and we learn. And this can totally be a message reference. We don't need to actually hold on to it. All right, we don't like this because it's more private than that. Okay, whatever. Whoops. Yeah, because it uses the public API, it uses something that's too private. Whatever. Okay, go away. Okay, fantastic. So we have a send message thing. And we could make that part of the message. We could make that part of the message implementation, actually. It does sort of, now it does sort of muddy the concerns a little bit. It's easier to say send message and then have a really simple C-like interface. You can tell I'm a C programmer. A little bit at heart, if you will. All right. And so now we can do send message, mute stuff, right? Client ID, and we're gonna send a message, system message of hey bitch. Let's make this str. Well, let's not make this str. Just sending a system message is not allowed. Goodbye. I should probably say something like, ooh, nice try, but I'm good. I'm good. All right, fantastic. Missing a semicolon there, and in a way it's that. All right. Sending system message is not allowed. Good luck. Goodbye. Fuck off. And then here we're probably going to do the same thing. Kicking client because they have not logged in. You must first log in. Log in. That's how it is. All right, fantastic. So and then we return, I guess. Oh, can we return? Yeah. All right. And so now we say we now get content. And so this is where it gets interesting, right? So now we get content from a client that we know exists and that we know is actually sort of legal, real, if you will. And so let's keep track of clients by their client ID and their name, because I don't see why not, right? Just might as well. Oh yeah. Partially cute. Very smart, very smart. And of course, we can no longer do contains, but we can do a inner any what's it like? Client ID is client ID. Fantastic. And then we don't actually need to derive partially Q because there's no point. All right. And how about we take this code actually, and we extract that into a little function. Call that function get client. Yeah, that looks good. No AI used, by the way, so far. Pretty cool. Pretty cool. Still got it. All right, so this is sort of our check. I guess it's kind of ugly, but that's fine. And then in the else case, I guess we just really want to broadcast it to our clients. So for clients in self clients, we want to say client, well, we want to do net send tagged packet. And no, I guess that's fine. I guess that's fine. I guess that's fine. And the chat message should probably also contain a name, right? Or does it? Should it? There's actually no point. I don't know what the fuck I'm doing. Oh, no, there's a point because we need to know where it's coming from because otherwise the clients can't display it. Oh, what if we just hack it? Let's just hack it together. Who gives a shit? This is really fun. All right. I'm having way too much fun with this. So mute self, right? Again, we don't have to care about which client it is because all the clients are multiplex, right? So tag packet data. And well, in this case, I think we're fine. So we want to do client ID is client, whoops, client ID. And data is gonna be a, let's do data and just declare that. So that data is a message, or this is gonna be the message, right? So get message from with the content. Actually, we want to format it first. See what I'm doing? It's horrible. And so we'll take the client ID. Oh no, that's not what it is. We want to take the client. Let's move this out into a variable actually. Client. And wait, does the get client return a bool? Oh, that's retarded. Oh, sorry, I shouldn't say that word. That's retarded as fuck. That's what I meant to say, of course. Oh, what's it called? Filter. Well, first, I think. What's it called? Next. And that doesn't return an option? What the fuck does that return? Oh. Oh, found enum client. I guess it doesn't really matter. Don't care. This doesn't have to be mute. There's no point. All right, so now we have the client. So if client is none, and then otherwise we do let client is client unwrap. Okay, so now we have the client. So now this is gonna be client's name and then the message, so content. Fantastic. And of course we then send that because the data is survey JSON to vec message. And we send that as the message. And that doesn't work because expected, oh, no, what the fuck is this? Found future, oh, whoops, sorry. Inside of this loop, blah, blah, blah. Oh, That's awkward. That's very awkward. That's very awkward. I guess it's fine. I guess it's fine though. It sucks a little bit that it consumes that because we have to clone it every time, but it doesn't really matter that much right now. Okay. Now, send that tag packet with the fucking name prepended, which is horrible. Let's at least do IRC style. And let's at least do IRC style. And that means that our system message will have to be system message. Let's make a little thing for it. Make system message. And so make system message will be take a string. There's a lot of meanings of message right now. It's a little wild, but it's fine. Let's keep this sort of let's keep this sort of generic. So it's going to be system. Oh, let's do like this. System message. Okay, so now we can call make system message with whichever message we had before, which is like sending a system message is not allowed. Goodbye. Fantastic. Brilliant, even, I would say. And then the other system message has to be the same thing. So make system message. You must first log in. Right, that way we make sure that we always prepend this little system thing. It's a little weird, but we'll just deal with it. All right. Okay. That's the sending of messages, the sort of echoing back of messages done. What else are we looking for? What else do we need? I think it's just a login. So we basically now want to do we want to do self clients iter filter or any c dot name is name. So if any of them are that, we want to actually send us a message saying you need to pick a different name. Name already taken. Try again with a different name. And then we'll kick them. It's only fair, of course. This is the fairest system I've ever seen. All right, name already taken, try with a different name. And that's all we do here. And else, I'll just do it explicit with an else here because I think that's kind of nice because we don't have to return that way. We say, okay, self clients push client where we have the client ID and the name. And that's good. That's it. And since this is an entirely single-threaded app, entirely single-threaded, like, I mean, the Tokyo stuff is not technically single-threaded in this case, but we could make it single-threaded. It doesn't matter, right? Our code is running in a single in a single sort of linear way without, the async, as I said, a little weird, but doesn't necessarily, it's just one single socket, so it doesn't really, there's no multi-threading going on here, reasonably speaking. Token response, blah, blah, blah. And then the one thing we haven't implemented is the failure, but we're just not going to do that right now. And I think that's all we need. I think we now have a working chat server in 158 lines of code. Fantastic. So cargo run. Fantastic, it works. I mean, I don't know if it works yet, but we're gonna figure it out, right? So we're gonna have a server. We're gonna basically move everything into the server, because that's fun. And yeah, so now that everything's in here, we can now make a new cargo toml, and we can make a workspace, and we can say members is, and Copilot is not cooking with that one. I don't know what it's thinking. Server and client. And so of course client doesn't exist, so cargo new client. Wonderful. So let's build it. And again, the server has one dependency that's important here, which is net, and the client will have the same one, or I think all the same ones, because it's gonna be doing mostly the same thing. So cargo new shared lib, like a shared library here for all the code that's shared, which is exactly this. That's what's shared. And what that means, we can sort of take all this shit and yeah, we can't reuse this thing, so I have to redo that. But that's okay. And so this needs Serde as well. It's fine by me. I'm not super fit about that. Okay. Okay, fascinating. We're doing such an interesting job here. Well, and of course, message is shared message. So use, but of course we didn't say that we want that. So shared path is shared. There we go. Oh, whoops. Cargo build. All right, fantastic. It's now building again. And we basically want this one in the client as well. So the client is also stupid simple. We're just gonna just steal the test client 2 here. Thank you very much. And the reason we're stealing it is because it's literally so simple. I don't even know, like, it's so simple. And instead of net, we actually want client con. But other than that, it's the same thing. Because if I have to rewrite this entire thing, I'm gonna cry. So, but I'm gonna go through every single line so you kind of understand what's going on. So this connects to the server, which is fair enough. Not our server, mind you. Our server runs on this port. This is the connection server that we didn't like. That's Vault Lane. That's completely separate. We then have a loop where essentially we have an input buffer, and we read from standard in. We then send that to the server. We then receive something from the server, and then we write it all, right? We're not going to use this specifically, right, for multiple reasons, but we're going to start with this, okay? Because most of this logic we do want. Okay, and you can see that we're now using client-com connection. Client-com connection is a pretty beefy class that does a bunch of random stuff like connecting, doing some sort of key exchange with the connection server, all sorts of funny stuff. But don't fret, there is a C library for it that has a very simple interface. So if you don't want to deal with all that shit, I mean, either way, this interface is simple, but if you want to not even touch Rust for your clients, because your clients shouldn't run Rust code for some reason or whatever, just do this. This is easy, very simple to use, and it has the entire functionality. Sorry, the entire functionality of the library that we're using here, client.com. So same thing. All right. So instead of doing standard IO, standard and read, actually I do need to nuke this. That sucks, but I do need to nuke it. And the way that this works is essentially like it's trying to reconnect us if we lose connection, which is kind of nice. We don't really need that, but we can do that. Oh god, it needs to shut the fuck up again. The Copilot's yapping. All right, so let's say that we want to do two things at the same time. We want to await. So there's a thing called Tokyo Select. And Tokyo Select is wonderful because you can say, okay, either I get my message, right? So, or my packet, which is, what's the syntax again? I don't know. Whatever. It's oh well, we have a using statement over here. So net receive size prefixed from the client read and await. And that's not quite right. What's the syntax again? I'm sorry. Oh, I think I'm missing a row here. That is most definitely what I'm missing. All right. And all right. I need to look at the others. Tokyo Select does. How am I using it again? No, that is the right syntax. Yeah, that is the right syntax. Fantastic. So we can say either we want to get a packet. So either this completes first, or, and now we have to kind of cook a little bit. So let's do that. So standard in is standard. Well, I would like Tokyo standard in. So standard in the read line. Is there a read line? No, there isn't. How do we read line from standard in without? I guess we just read, right? Standard in read. Yeah, I guess that's what we want. So we now want to buffer. So let each buff is gonna be what UA 0 is that? No, that's not how that works. 1024 0, something like that. Yeah. So now we will take our n is standard in, and this is gonna make sense in a second. Don't worry. Read buff. And of course we need to import some sort of this one. But essentially the way this works is that we say, I want to select on this. Wait, it's not a future. Oh, I can't wait, of course. The whole point is that I don't have to wait. It's probably already that, or do I need to do this? I think I need to do this. Integer. Oh, yeah. Whatever, good enough. No, it's not good enough. Never mind. How did we do it in the other one? Am I stupid? I think I'm missing something here. Oh. Yeah, I did it the wrong way around. I was like, wait, I remember doing it like this, but whatever. And of course it needs to be mute. All right, that was maybe the problem. I don't know. Essentially, Tokyo Select says, try doing this and try doing this. And whichever one completes first, that's the one we're going with, right? So you're basically racing the receiving of the packet with the receiving of a new line of input, okay? And this doesn't work quite well in this case. It kind of sucks, but it's going to get the job done for our little demonstration here. So that's going to be fantastic. So once we get the packet, we say packet, well, we match, well, I don't think there's anything to match on. It's just effective, right? So we say our message is going to be a message, which is a use shared message. And we say our message is message, which is 30 JSON from slice. And we take the packet as a slice. Please. Oh, interesting. Yeah, there we go. Okay, so that's now our message, and now we can literally just match on a message like we usually do. If it's a chat message, we say the message. So we just print line the message in its entirety. Okay, I think that's fair enough. And then login response. We don't actually allow this. So this again is unreachable. So the compiler can sort of be like, yeah, not a thing. And then system message. Well, I don't really need to do system message anymore. I don't really need that anymore, actually. Now that I've got the funny prefix, I think we can just get rid of it. And I'll clean it up later. But, oh, well, let's clean it up now. Let's clean it up now. So instead of system message, which we're not going to do anymore, it's going to be now a chat message, which sort of makes our little make system message thing make a little bit more sense as well. There we are. Okay, so we can either get a chat message or we get a log response, which is unreachable. And in this case, actually, everything else is unreachable. There's nothing else we can possibly care about. Yeah, fantastic. And I think this whole thing we want to put into a function because of reasons. Can I not extract this into a function? Okay, fantastic. I'll have to do it myself then. You really can't? That's so wild. Isn't that wild? Okay. It's called run. Take the client as a connection. And we'll take this thing and we'll take the client waits if that is this print line error. Actually, I want to get rid of this. It's kind of ugly. Yeah, I want to get rid of that. Let's get rid of it in the server as well, because I don't think that's very nice. This colon doesn't really make sense if we have this format. All right. Where was I? Okay, let's keep going with this because we can. And then we can try to reconnect. And the thing is, if we failed because of any reason other than that we were kicked, it's going to let us reconnect. But if we were kicked, of course, it's not going to let us reconnect. So this is going to fail, going to break, and we're going to be done. dunzos, if you will. Okay, so and if we have this, what we do is we read, which actually returns us a read thing, which means that we now take that and make it into a string. And in this case, actually, I do want to turn on the AI again because I cannot be fucking bothered. Thank you. Fantastic. I don't want this. So client send message is not a thing, but cute idea. Very, very cute idea. All right. I want to send prefixed the client writer. All right. Yeah, that's what I want to do. And then of course this isn't break. I guess it is. I don't know. I guess this is the case in which we try to exit. In which case I think we can standard process exit. We can standard process exit because you know. Yeah. Fantastic. Now the only thing we're missing, and I'll actually try this. I'll actually try this out because why not? So cargo run release bin con server. So this is going to be the connection server, and cargo run bin server. Oh, it's not called that. It's called Vault Chat. Okay, renaming it. Okay, so server should be running in a sec here. Nice, server's running. So now we can run this. That works. And so now we can do cargo run bin client. And so it's going to connect, I think. So vault lane should, yep, there we go, connection. Our server hasn't said anything yet. And so when we say hello, it'll say us, you will first must log in, I guess. And it keeps kicking. Oh, I think kick is not implemented yet. Is it unexpected packet from client 0? I think it's for client 0. Kick. Yeah. This is a bug. Interesting. Very cool. But essentially, we get the message. It's kind of unnecessary to kick the user regardless, but yeah, it's not a real thing. And now you can see that it's now error receiving packet, error handling client duplex. And what's going to happen in a second is that it's going to time us out. Yep, there it goes. And oof. Oh, I think the master server crashed. Yep, it did. Because the client failed, this crash was not yet implemented, and Vaultlane at the moment is designed to fail as hard as possible as soon as it realizes that the master server is down. So that's fair enough. That's not really a bug. Well, it's a bug in the current program we're writing. Maybe we should just implement this before we have more problems. Print line. Yep, let's just do that. And that's gonna be good enough. And then we also remove that. So self clients retain where that's not that ID. Yeah. All right. We've done a pretty good job, I think. Now let's try that again. So let's run the server, let's run Vaultlane, and then we try Vault Chat again. And now it should actually kick us. It has not kicked us. It has not. Oh, yeah, because we haven't implemented that. But now when the server disconnects us properly, we should see that everything doesn't crash anymore. Yep, it just crashed. We got client 0 failed, client disconnected, because of course they failed to authenticate and we tried to kick them, but then didn't actually get kicked, which is a bug on the Vaultlane side, of course. Implement kicking properly. All right, there we go. Oh, I just killed it. My mistake. My mistake. Oh god, come on. Why is it so hard to copy things from this console? Right click, copy. There you go. So right now, if the client tries, if this master server, oh god, tries to kick a client following bug happens. Really, we only need one of them. That's a bug, and let's create that. All right. Okay, fantastic. So now that this is up again and this is up, let's now implement the last step in the client, which is basically before we run, we want to pick a name. Okay, so print enter your name. We do flush, which is correct, and then we make read line. Sure, trim it. Why the fuck not? Good idea. Sure, cannot be empty. And then this is essentially what we want to do. But client send name is not a thing. So instead we want to construct a packet for it. So let pack login packet is message. It has no idea what the fuck's going on. Login response name. We then serialize it, and that's it. And I do really like fuck yeah. I do really like the AI for things like this where I really can't be bothered to like write the same shit again. Like, you know, do this step, do this step, do this step. Of course, you could write a pretty abstraction for this, but this is a throwaway project. I'm just trying to build something fun, to find bugs like this. And the fact that this is the first bug we found is actually pretty fucking good. I think I've done a pretty good job so far, considering that's the first bug, and it doesn't save the fucking website color. That's embarrassing. All right. I thought I wrote that into the local storage, but I guess I didn't. Okay, so now let's try again. Run the client, enter your name. It's online. All right, fantastic. And let's open the second one. Peter. Peter. No, let's do Peter. Hello. And so now you see Peter said hello. And I could say, hey, what's up, dude? And you can see that I said, hey, what's up, dude? And he got, hey, what's up, dude, on his side. And I think we also should trim the messages before we send them, because it's a little strange to be doing it like this. Buff dot oh no, message trim. And as you can tell, it's kind of not that terrible. Oh, name's already taken. Oh, did I not disconnect yet? Oh, that's well possible. Okay, now let's try again. Yes, now it works. So I was still, like, it was disconnected, but it wasn't like fully disconnected. It was still allowing me. So at this point, I want to just show what happened. So I was fully disconnected, and but I tried to reconnect, and actually this allowed me from reconnecting because I tried to take a name that was already taken, and the master server had not yet realized that the name was free again, because the connection server keeps the connection around for a little bit in case you want to reconnect. You can configure all of that here. it's fantastic. But if I may say so myself, of course. So let's read some messages. So hey Peter, hi Line, are you schizophrenic by chance? No, are you? Yeah, I can't complain. Works. And now we can have as many clients as we want, right? This is never going to be a problem. And also, don't want to flex on anything, but there's a heck of a lot of no CPU usage from any of these programs. If I filter for server, there it is, doing nothing. If we look for the client, down here somewhere, both of them, I mean, they use quite a bit of memory, 4 megabytes, you know, but they're doing nothing. And the con server, probably the biggest one, which should occasionally spike a little bit in CPU usage. But really, I mean, yeah, it's not doing anything. It has 9 threads though, which is funny. But yeah, so it works, and I'm actually really happy about this. Because genuinely, I didn't think it was going to be this easy, and I thought I was going to run into more issues, but I guess I didn't. And so I'm going to send this to my friends in the Discord server, which is linked below. If you stuck around until now, thank you for listening to me yap for an hour and 11 minutes. Make sure you subscribe. Genuinely, just click the button. Just do it. Come on, you know you want to do it. And I'll see you in the next one. Thank you very much for your time.